Hello everyone, thank you for joining today's webinar. I'm Ursula Barr, Category Marketing Manager for Digital Power at Schneider Electric. So I look after our metering portfolio and our power quality equipment. If you'd like to add me on LinkedIn, you can scan the QR code or follow the link on the screen. So today we're going to be talking about operational efficiency at university campuses with a focus on the power equipment. So first of all, we're going to discuss what campuses need to do. Campuses need to, first of all, reduce downtime for occupant comfort and safety. There's so many buildings on a university campus that you need to ensure that all of these are running smoothly at all times, especially with the vast number of students and staff within the university. We're dealing with quite a lot of people, so it could be quite a disturbance if the facilities aren't running correctly. We also will be able to detect maintenance issues on equipment and anticipate power distribution issues. This is done through software solutions where we can look at things remotely and be able to detect where power is being used, if there's too big a draw from particular areas, and we can use this to anticipate future issues. And ultimately, you want to reduce consumption. With being such a large site, a university campus will draw a lot of power from the grid. And with a big focus on sustainability and reducing our carbon emissions, we want to minimize this consumption. So the different power distribution load types within a campus are ranging from critical loads to loads that maybe don't even need to be on. So the easiest way to look at this is if we view the university campus as a mini city, which they tend to be these days. You've got buildings such as accommodation, you've got data centers, you have generation from wind or energy, we have electric vehicles. Basically everything that would be contained in a small city, we tend to have within a university campus on a much smaller scale. So our critical loads, these are emergency lighting, data centers, CCTV, medical facilities. These are the loads that need to ensure constant uptime and no disruption. These are the ones that, if they're not working correctly, they could cause major issues both to the occupant's safety, well-being, and also legal issues. You can have severe fines for not having emergency lighting working correctly if there's an incident, etc. Then we also have standard loads. These are the loads that are vital to the running of the university, such as accommodations, study areas, sports facilities. These are the ones that we want to ensure constant uptime on, but aren't as critical, aren't as vital to occupant safety. But then we also have other loads. We have the likes of load planning, which will have a look at room occupancy. So if rooms aren't occupied, we can arrange for the demand to be shut off or supply to be shut off to that room, so it can be redistributed throughout the rest of the building. But then we also have very energy intensive things such as power generation. So between solar, wind, these are green initiatives, and they are beneficial for the site. They're not reducing the draw on the grid, they're actually improving it, but they're energy intensive in terms of the equipment they require, and they also require energy storage as well. And also with electric vehicles becoming huge in the future, we need to ensure that the constant supply delays, and these do put a big demand on the grid and cause large draws, which may even cause you to look at applying a microgrid to your university. So our electrical solutions for this, first off and most importantly, power availability, making sure everything is running smoothly and has constant supply. Safety and reliability are of course key issues. Given the high power nature of the equipment, we want to ensure that these can be safely operated on when need be, but also that they're safe for all occupants. We need to ensure everything's efficiently running, and this is both to reduce OPEX and improve sustainability. So you want to reduce the amount that we're spending on energy, but also make sure um, that we're putting out as few emissions as possible. And of course, we want to make things easy to install. This is mainly because universities are live 24/7. They don't shut down. Of course, some buildings will turn off, and this is where load sharing comes in, but a vast majority of buildings on site will need to be maintained constantly. So we don't want to have long downtimes in order to perform maintenance or to install new equipment or, of course, test the system. So just looking at a university campus, we have so many buildings that are critical and that require different demands. Phalanx of a hospital where patient and general occupant and staff well-being is critical, and this requires a lot of high power equipment that we want to make sure is receiving the best quality power to it. But then we also have facilities such as sports facilities, and although these aren't on all the time, they're only used in certain instances. When they're on, uptime is vital. So you can remember, for example, the Super Bowl in 2013, whenever there was a power outage which lasted about half an hour, and this caused global news. Everyone knew about it, even if you weren't following the sport. And this was simply because a relay was installed incorrectly. So yes, they were using the right equipment, but it hadn't been installed correctly. And what we want to help you do is make sure that your system is running properly before it reaches a point where it's critical. For example, we have software options which monitor all your equipment in real time, but can also be used as commissioning tools. So without actually running everything live, we can see where power is going, the general path of it, and see if something's not reaching its final destination. So if an asset is supposed to be running and it's not, then we can look into that and send someone to have looked in maintenance or check the general stream of it and make sure there are no interruptions during it. But in most of our buildings, we'll have solutions such as metering. We will look at where demand is and how much it's drawing. So for example, in a data center within the university, we will look at the supply to each server and see where that server is connected to and where the draw is on that. We will also look at campuses, campus accommodation and libraries, see where supply is. And we can also use this to provide initiatives for students and staff, such as turn off light initiatives, do reward schemes, which have proven to be very successful in the past, and drives the whole sustainability message throughout the entire staff and student. But just looking at it in general, we will have everything on here equipment wise, from HV, from the demands, from the grid down to individual assets. And if we look at all these connected assets, what we really want is a software option that provides visibility through all of your network. And this can be done through power monitoring software and SCADA software. And these provide insights that you wouldn't get just from having the assets alone. They provide critically power quality analysis, which will tell you not only how your assets are performing, but what the power is like being delivered to them. So, for example, it will check the power factor and if there are any harmonics or spikes or sags or swells on your signals. And these not only increase your operational expenditure because you're essentially paying for power that isn't as useful or not useful at all, in fact, but you're also severely damaging your assets. Because if you're delivering bad power to a particular asset, it will wear it out over time. And you may wonder how these power quality issues come about. These are particularly prevalent um, in modern society because of the increase of LED lighting and variable speed drives. And these, although they are great for sustainability and is highly recommended to use them instead of incandescent lighting, for example, they are active loads rather than passive loads, which means they contain a lot of diodes and transistors, which will put harmonics on the system and also damage the power factor. So it's not enough just to identify these issues. We have to also have to be able to act on them. And that's where our power quality solutions come into play. So we can fix these issues and ensure that the supply is as smooth as possible and that your assets will last longer and require less maintenance. And again, we can still use the software to ensure this is constant and always the case. So looking at individual players within a university campus. First off, the operations team are vital to the running of the campus. This is because they're actually out looking at issues, fixing them, making sure that everyone's comfortable and that there are no disturbances to any of the facilities. So you want to make their life as easy as possible, because as we know, they tend to be overworked as is. So by having software dashboards, we can ensure proactive maintenance of the entire system. So you can identify issues remotely rather than having to do manual inspection. And this not only flags up issues straight away, but also reduces the amount of scheduled checks you need to make. And this drives asset lifetime, meaning that the amount of maintenance that's required is much lower and replacement happens less often. And of course, there are huge benefits to their safety. So rather than working with live electrical equipment, they're able to look at things remotely and assess what priorities are. And as well, they look after occupant comfort. So they make sure there are no flickering issues, which in a university, if you're in a library and the light's constantly flickering, you're going to receive a lot of complaints from the students because it's going to affect how well they can study. So this ensures that they're comfortable and that things are running as we want to. So for the estates director, they look after the financial performance of the university. So they want to reduce both OPEX and CAPEX. So they want equipment to have visibility through connected devices. This means that, again, we're shutting off supply to places that don't need it. We're looking at the entire system as a whole, and we're managing our energy efficiently. Again, if we're delivering good power quality as well, we'll be spending less on reactive power and less on maintaining equipment because it will receive less damage. And in terms of reducing capex, we don't need to replace equipment as often, meaning that the investment you make straight up will last longer and require less retrofitting. And finally, for the Sustainability Director, there's a huge focus globally on reducing carbon emissions in order to ensure that we don't use all the resources available. So we've all heard statistics of if we keep our demand the way it is, we will get through all supplies globally in far too fast a rate. So of course we want to ensure we can minimize this, especially on areas as huge as universities, which do have a large demand. So this is done by making buildings smarter and being able to anticipate demand. Again, look at the look at the look at what we're taking from the grid, seeing if we can have sustainable ways of generating energy, such as solar panels and wind farms, and making sure that if we do have these, that the energy is being stored correctly and that we're not wasting any of it. But also in terms of sustainability, we want to increase asset lifetime and reduce the amount that's going to landfill, which is a huge issue, especially with electrical equipment, which can sometimes have damaging gases within them, and these can be huge detriment to the environment if they're disposed of. And of course, we want more efficient asset performance so that each asset is drawing less power. So thank you very much for joining us today. Again, if you would like to add me on LinkedIn, you can scan the QR code or add me in the link, and I hope to hear from you soon. Thank you.